Hi guys, welcome back to Randland Tutorials by Mary Ann, and we are going to continue with mechanical energy. So grab your pen and your paper and join me for the ride. So the first example reads, a crane gradually lifts a car with a mass of 1,200 kg at a constant speed to a height of 6 meters. Calculate the potential energy of the car. The equation of potential energy is given by mgh, where m stands for the mass, which is always in kg, g stands for gravitational force, which is a constant, and h stands for height, which is always in meters. Example 1 states, a crane gradually lifts a car with a mass of 1,200 kg at a constant speed to a height of 6 meters. Calculate the potential energy of the car. To begin with the question, we are going to write down the information that is given, which is the mass is equal to 1,200 kg, and the height is 6 meters, and g is equal to 9.8 meters per second squared. All right, and they asked us to calculate the potential energy. So potential energy is given by mgh, and we are just going to substitute as it is, and the height, which is 6 meters. All right, sorry about that, this is a 6, not an h. All right, so the answer to that gives us 70,632 joules. All right, and that's how we answer the first question. Very easy, very simple, just pure substitution. This question is taken from Mind Set Learn, grade 11 physical science, and it reads, Tarzan with a mass of 80 kg is on a quest to save Jane. He will run towards a rope with a velocity of 12 meters per second. He grabs the rope. To what height will Tarzan swing? So in this particular question, we are going to draw a sketch. So this is Tarzan, and this is the rope. Say this is Jane. This is where Jane is. This is the rope that he is carrying. I'm so bad at drawing. So this is Tarzan. Let's scratch this Tarzan. This is Tarzan, and he's holding a rope in which he will swing to get up to Jane. All right, this is where Jane is standing. All right, but you get the picture. All right, they're looking for height. At what height will he get to? So with the information that we have, we are going to start calculating. So we are given his mass is 80 kg and his initial velocity is 12 meters per second. So whenever you see that there is a change in movement, all right, so you start off by running and then you are jumping or something, that change should indicate which equation we are using. All right, so the equation we are going to use is mechanical energy initial is equal to the mechanical energy after. In the first video, I stated that if there is no friction, we are allowed to use this equation. So we were never told anything about friction, so we are going to assume that there is no friction, or there is no air friction. Not that there is no air friction, but we are going to ignore air friction. All right, so the equation is mgh plus a half mv squared, all initial, equal to mgh plus a half mv squared. All right, this is all final. All right, so now note, we do not have the initial height. All right, but now if you think of it, I am running, I am standing on the ground, so my initial height will obviously be 0. All right, so I can write it here on the side, 0. And the final height is what I am looking for. All right, And then I do not have the final velocity. So what happens if you throw something? It comes back down and it comes back down to the position in which you threw it. So immediately you throw it, it loses speed until it gets there and then it drops. So when it's at its maximum height, the velocity will be 0. So V final will be 0. And then afterwards, we just substitute. So the mass is 80, G is 9,8, height initial is 0 plus a half, 80, V initial is 12 squared equal to 80 times 9.8. Height initial, height final, is what we are looking for. Plus a half, I don't know if you can see, plus a half. M is now 80 and V final is 0. All right, I hope that you understand why it's 0. It's 0 because when an object reaches its maximum height, the velocity at the maximum height is always 0. All right, then you just put this in your calculator, in which we are going to have 5,760 equal to this side, it gives you 784 HF, and to solve for HF we're going to divide both sides by 784. So my final height I get is 7,34 meters. All right, the last question is the Challenger, and this is also taken from Mindset Learn. All right, so it reads: a roller coaster car 500 kg starting at a point of 80 meters above the lowest point of the track. The car travels from 8 meters per second down the steep track. There is no friction. So when they say there is no friction, please note that you can use the mechanical energy initial is equal to the mechanical energy after. So to start off with this question, we're going to write down all the information which is given, which the mass, I hope you can see, the mass is 500 kg. My V initial is 8 meters per second, and my height initial is 80 meters. All right, and you can see in the diagram, height final is given by 15 meters. So the first question asks, what is the total mechanical what is the total energy at the top of the track? And that's basically just asking for the mechanical energies. Mechanical energy at the top of the track is equal to mgh plus a half mv squared. All right, always remember to write down your equation, and we're going to say this is 500 times 9,8 times the initial height, which is 80, plus a half, the mass is 500. Just move this so you can see, 500 times the initial velocity, which is 8 squared. And if you put that in your calculator, that gives us 408,000 joules. All right, then the next question asks, what will be the potential energy or the total energy as well at the bottom. Now remember, they told us that this whole track is frictionless, so therefore the mechanical energy at the bottom will be exactly the same. And what is the reason for that? Conservation, law of conservation of mechanical energy. All right, which states that the mechanical energy initial will be equal to the mechanical energy after in an isolated system. So the next question asks, what is the velocity of the car at the height of 30 meters from the base of the roller coaster track? So we have agreed with the previous question saying that the mechanical energy at the bottom will be equal to the mechanical energy at the top. So the mechanical energy at the bottom is what we're trying to find because now it moved to 30 meters. All right, so we're just going to write down our equation. And the mechanical energy at the top still remains the same, which is 40800. All right, so the mass is still 500. And we're going to multiply it with 9.8. Now the height is 30. All right. Plus a half 500 v squared equal to 408,000. And remember, these are two terms, so I'm going to take this to the other side. And a half times 500 gives me 250 v squared equal to 408,000 minus 500 times 9.8 times 30. All right. Then you are going to divide both sides by 250. Remember, this whole thing is divided by 250. Then we are going to get rid of the squared by rooting both sides. And my velocity will give me 32.31 meters per second. All right. On the last question, we have to find the velocity at the base of the track. So base means at the bottom of the track. So we're still going to use the same equation, E mac bottom equal to E mac top. And this is mgh plus a half mv squared at the bottom because we're trying to find the velocity at the bottom and we don't know the height at the, well, we do, which is the ground, so it's 0, and the mechanical energy at the top is 408. That does not change because it is a frictionless surface. All right, so the mass, we're going to substitute 500 times 9.8 times the height, which is 0. And it's 0 because it's at the base, which is at the bottom of the track, and that is 0. All right, on the ground, plus a half times 500 v squared equal to 40800, and we're going to solve for v squared. This falls away, so this becomes 250 v squared equal to 408,000. We're going to divide both sides by 250 and root. And v then gives us 40.40 meters per second. All right, and that is how you answer mechanical energy questions.
Hope that this video was helpful. Don't forget to like, comment, and subscribe. See you next time. Bye.